So time to start the organic chemistry topic, and we're going to start by looking at hydrocarbons. We're going to do this over a number of flipped lessons. So in part A, we're going to look at how we represent the formula of hydrocarbons, and we're also going to look at nomenclature, which is a fancy word for how we name hydrocarbons. Let's get into it. So what is organic chemistry? Well, organic chemistry is really the chemistry of living things. Anything that's alive or living tends to be organic and based around organic chemistry. In terms of the atoms, it's really carbon-based chemistry. All organic molecules are based around carbon atoms, and generally carbon with hydrogen, oxygen, and nitrogen. And to a lesser extent, some things like sulfur and phosphorus and chlorine are also seen, but really the main one is carbon, and then hydrogen, oxygen, and nitrogen are the other three main ones that we will be interested in any of the organic chemistry that we will do this year or next year. Now, the first thing that the SACE board says that we need to know about is we need to know about representing, so firstly, hydrocarbons. Hydrocarbons is really hydrocarbons, if you like, are a branch of organic chemistry where we have molecules that contain hydrogen and carbon. And sometimes we also include things that contain oxygen into those hydrocarbons, but generally when we think about hydrocarbons, we're thinking about the same sort of thing as organic chemistry molecules. So we need to know about empirical formula, molecular formula, structural formula, including extended structural formula, condensed structural formula, and skeletal representations of structural formula. And I'm going to go through this here in a sec. And we also need to know about the idea of things called isomers. So let's get into it, and let's start with a compound that you may probably have hopefully heard of, and that is something called butane. Butane is found in lighters, cigarette lighters. It's also found in those cans for camping ovens, camping stoves. So camping stove fuel. So it's a reasonably common molecule that you may have come across. So let's talk firstly about a molecular formula. And the molecular formula for butane is that's not what I want. The molecular formula for butane is C4H10. It's got 4 carbon atoms and 10 hydrogen atoms. So the molecular formula, if you like, is the summary of atoms that the molecule, or the summary of the atoms present in the molecule. Let's go with that. And we use molecular formula a lot. Now, there is also something called an empirical formula, and the empirical formula is the simplest ratio of atoms present. Simplest ratio of atoms present. And just move that out the way, of atoms present. It's a bit messy. And we don't use this as much in organic chemistry, but in this case, you know, if this was a mass problem, you would say C4H10. Well, that can be simplified to C2H5. There's 5 hydrogen for every 2 carbon. That's that simplest ratio. But again, not one that we commonly worry about in organic chemistry, but you do need to be aware of what an empirical formula is. Next is the structural formula. So the structural formula for this would be, in a sense, what it looks like. However, we do cheat a bit, and let me draw it out and then talk about the sheet. The structural formula here is butane has 4 carbons. These carbons bind to each other. This is carbon. Carbon likes to share electrons. It has 4 electrons in its outer shell. It's a non-metal, so it likes to share. So it tends to bond to lots of other things because it's got 4 electrons to share. And in particular, it likes to bond to itself. So we get a lot of these long carbon chains. And then coming off this, there will be 4 shared pairs of electrons, i.e. 8 total electrons, because a shared pair of electrons is a pair of electrons, and a chemical bond is a shared pair of electrons. So that is the structural formula for butane. Now, the cheat that we use is, someone should be hopefully now going to me, oh, but you will get a tetrahedral arrangement around each carbon because you've got 4 atoms, and we did valence shell electron pair repulsion theory with you early in the year, and you would be correct, but it's very hard to try and draw this out with all the tetrahedral and join up. So we generally simplify it and draw it in what we would call this 2-dimensional square planar type format. But if you're thinking, yep, should these all be tetrahedral, 4 pairs of electrons, you are correct. Now, often that gets a bit tiresome, so we do what's called a condensed structural formula, and that looks like this. We've got a CH3, CH2, CH2, CH3. So that would be our condensed structural formula for butane. And sometimes we even get lazier, or we're drawing really big molecules and we don't want to draw too much of this, and we do what's called a skeletal formula, and that would look like that. And what basically, in a skeletal formula, let me just use a fainter colour here. So the red is the skeletal formula. Maybe actually I'll draw it out again here to show this bit. That's the skeletal formula. And basically wherever you've got the end of a line or a bend, that indicates where there's a carbon, and that carbon has its full complement of hydrogens. So there's our skeletal formula for butane. The one in red there, I've just drawn that yellow in to sort of highlight what that's showing. And the other thing we need to know about is things called isomers. Isomers have the same molecular formula, but they have a different structural formula. So I've drawn here butane, C4H10, but I also could have drawn out this molecule here. I'm going to have to do it over here to give myself room. Let's say if I'd drawn out I'll draw out the full formula actually, because we're just starting at this. I won't go straight to condensed formula. If I'd drawn out this molecule here, and just give me a sec. We could count up there and we would see 1, 2, 3, 4 carbons. And this would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it is still C4H10. So it's got the same molecular formula as butane there, but this isn't butane, this is an isomer of butane. This isomer, we're going to learn how to name this in a minute, is called 2-methylpropane. But won't worry about the naming yet. We'll look at that in an upcoming slide. Okay, now we are going to learn how to name some of these hydrocarbons, or some of these organic compounds. And it's important, you know, there's so many different of these organic compounds. We need to have an unambiguous way to name and identify them. And we call this systematic nomenclature. I always struggle with that word. But it basically means the science of naming things. And you need to be able to name hydrocarbons with basically up to 8 carbons in them in their main chain, and with also some side chains, which I'll talk about in a sec. And hopefully you'll see, it takes a little bit of getting used to, but this system works pretty simply. The first thing we need to do is identify the longest straight carbon chain in the molecule, and that tells us the start of the name. If that is 1 carbon long, hang on a sec, we'll just use a pointer for a sec. If that's 1 carbon long, it's meth. If it's 2, it's eth. If it's 3, it's prop. If it's 4, it's but. If it's 5, it's pent. 6 is hex. 7 is hept. 8 is oct. You can think of octagon, heptagon, hexagon, pentagon for those ones to remember that. And then, in this case here, these are all just contain carbon and hydrogen bonds. So if they just contain carbon and hydrogen bonds, the ending of the name is ane. So this first one here, it contains 1 carbon. That would be methane. The second one here, 1, 2 carbons. So the starting of the name is eth from up here, ethane. The next one here, we've done a condensed structural formula. 3 carbons here, so that would be propane. Now we did butane in the last, so you can probably now see where that name comes from. We've got a skeletal formula here, so we've got 1, 2, 3, 4, 5 carbons. 5 carbons here is pent, and it's just carbons and hydrogens, so that would be pentane. Now we get into some where we have some branching going on. So in this first one, we've got to work out what's the longest straight carbon chain. And we can either go 1, 2, 3, 4, 5, 6, but we better check this way. 1, 2, 3, 4, 5. No, we pick the one that's longest, it's 6. What about if we go this way? 1, 2, 3, 4, 5, 6. Oh, now, it doesn't matter actually which one that's 6 you choose, you'll get the same answer. So let's just do it as it's drawn. 1, 2, 3, 4, 5, 6. So, because it's a 6, it is a hex. It just contains carbon and single bonded hydrogens. So it's an ane, hexane. But now we have to name this side chain. Now this side chain has CH2, CH3, like this one here. So that is what we call an ethyl side chain. So we put at the start of the name ethyl, hexane, and that ethyl group comes off the 3rd carbon. So we go 3 ethyl hexane. Now you might say, oh, what if we'd numbered it from the other way? Then we would have had 1, 2, 3, 4 ethyl hexane. Why is it 3 ethyl hexane, not 4 ethyl hexane? You always number it so you get the lowest possible number. So because we get a 2 there, that's the lowest possible number. Well, 2, sorry, we didn't get a 2. Because we get a 3 there, 3 is lower than numbering it from the other end and getting a 4. So that becomes 3 ethyl hexane. This next one here, again, we've got to find the longest carbon chain. 1, 2, 3. Now we could have gone 1, 2, 3. Oh, sorry, use the pointer. 1, 2, 3. 1, 2, 3. 1, 2, 3. But it doesn't matter whichever way we did it, we'd get the same answer. If you don't believe me, you can go around and check later. Now, 3 carbons, so it's prop. Just get a pen, sorry. Prop. It's all carbons and single bonded hydrogen, so it's an ane, propane. But now we have 2 side chains we have to name. Now, CH3 side chain is a methyl side chain. Now, because there's 2 of them, we say, not just methyl, we go dimethyl. So the di tells us there is 2, and both of them are coming off the 2nd carbon, so I'm running out of room here, but that is 2, 2 dash dimethyl protein. 2, 2 dash dimethyl propane. We go with a big one here, skeletal formula. And we are going to go longest carbon chain, 1, 2, 3, 4, 5, 6, 7. You can check the others, but 7 will be the longest. Because it's 7, it is going to be hept. And there's just all single bonds, so it's heptane. And then we've got three side chains to name. We've got a methyl, and an ethyl. That would be a CH2, CH3 there, if you drew that out in full. So, which one do we do first? Well, when you decide between ethyl and methyl, you do it alphabetically. So, the first part of the name, and sometimes it gets hard to get your space right here, would be the ethyl. So that would be 4 dash. We put a dash between numbers and letters, and we put commas between numbers. 4 ethyl. And then we're going to go to some numbers. So we're going to dash again. And then we have got on the 2 and the 3 carbons, 2, 3. And I'm going to run out of space again here. Put another dash because we're going between a number and a letter. And we've got 2 methyl groups again as well. So that would be dimethyl, 4 ethyl, 2, 3 dimethyl heptane. Now, the other one that you do need to name, which I've just realised that I didn't draw here, let's do this in a different colour, is where we have alkene groups. And an alkene group is just a carbon-carbon double bond. So it has a carbon, hang on a sec, it has a carbon-carbon double bond. Sorry. Carbon-carbon double bond somewhere in the molecule. And when we get those, instead of calling it an ane, the ending of the name becomes ene. So let's just do an example here. If we had this molecule here, let's say HCH, let's have a H down here. Let's try and be a little bit tricky here and put a CH3 here. Got a bit of a combination of 2 structures happening now, and part condensed, part full structure. That's fine. When we come to name this one here, we would go longest carbon chain, 1, 2, 3. So it is a prop. Now, because it has a carbon-carbon double bond here, it is a propene, and that carbon-carbon double bond starts on the number 1 carbon. So that's 1 propene. So, again, you might say, what if you'd numbered from the other way? Wouldn't it be 2 propene? You go so it's the lowest possible number. So 1 is lower than 2, so we would label that one 1 propene. So that is an introduction to naming hydrocarbons. We're going to do more and more of this with different types of hydrocarbons as we go on a little bit this year, and very much more so as you head into stage 2.